Greetings, dear colleagues. My name is Dmytro Dashenkov, and today I will be presenting the paper submission called Dataset for NLP-enhanced image classification. The goal of our research is to build a dataset as a proof of concept and as a valuable dataset on itself. Testing the multi-modal approach is with this specific data set is also part of the goal of this research. So let's start with the data. For the basis of our corpus, we gathered the image data from the data set called Open Images. Open Images is a public data set. The data set contains many different types of labels, which are human operator labels. But as we know, human operators, as any humans, basically aren't perfect, and the labels generated by human operators aren't perfect either. So as you can see on the slide, this animal is marked as both a cat and a lynx. So one of those is obviously a mislabel, which is not ideal for a machine learning model to have such kind of noise on the input data, which is supposed to be raw and clean. Text data is sourced from Wikipedia. In particularly, we take the name of the class of the label, which is assigned to a certain image, and we take either the exact match or the closest match of a Wikipedia article for that name. For example, for the label cat, we do have a Wikipedia article that is called cat, so that's what we're taking. The primary valuable information here is concentrated in the first couple of paragraphs. We don't need the whole thing, we don't need the whole article, only the definition of what a cat is, and that's what we're gonna work with. Of course, the definition is tokenized and stored in such a way that we can easily access it and process it with a machine learning model. So the data set that we get by gathering data that way, we call it image D data set. The general structure of it looks something like this. This is as you can see, there are multiple image classes and multiple images. Each image class has one text description, which is unique, and each image class corresponds to many images, as well as each image can have multiple image classes, which means that one image can contain, for example, a person and a cat and a dog, and they map to this, all of them map to this image. So let's take a look on what we can do with this data set, what we can do with this structure, and build a little experiment as a proof of concept. We will try to build a image tagging model which takes one picture and outputs several one-word tags which describe this picture more or less adequately. And with this in mind, we would like to cancel out some of the human operator errors that we talked about earlier. And basically, this whole exercise is done to verify that the data is quite adequate and that we can rely on it better than just the labels from the source dataset, which would be open images. On this slide, you can see the general schema of the labeling model that we've built. The core of the model is provided by the ResNet network, which is pre-trained, which is one of the standard networks for image classification and image processing in general. The ResNet takes batch input of 224 by 224 pixels image with 3 channels and converts it into embedding vectors, which are then fed into a fully connected head layer. The head layer is trained by us, and we train it specifically for this particular task. The fully connected layer is activated by the sigmoid function. The output of the sigmoid is then treated as a vector of probabilities for each particular tag. So to illustrate the results, let's look at some examples of what the model outputs for the given images. For instance, for this particular image, the model outputs four tags, which will always be 4 tags due to how the selection of the probabilities is structured. The tags are animal, bird, water, and street. Another example, which is a negative case where the model didn't work quite well, will be this image with the fish in an aquarium. The model did not recognize the aquarium, although it considered it to be sea or ocean, and it also found the fish, but it also output the tag mammal, which supposedly means that it doesn't really distinguish between fish and mammal, which is sort of the result we expected. So let's walk over some of the achievements that we have gained in the process of this research. First of all, we consider that the approach to collecting and reconfiguring data in such a way is quite successful, as shown by the model, which, as we think, performs quite adequately. Of course, it has negative examples, in which the model doesn't really perform good, but that is to be expected. And overall performance is quite well, and to the limit that we would expect such a model to behave. Images and text are adequately paired in this particular dataset. So the ImageD dataset is by itself a valuable artifact of the research and can be used in further research by us or by any other colleagues. The dataset is published on GitHub. And also let's take a look at what can we further improve regarding the work that we've done. First of all, collecting more data is always useful. We think that it would be beneficial to have some kind of a human supervision over the text data in particular, because automatically scraped text descriptions work well, but up to a point, and generating understandable, human readable descriptions would probably increase the value of the data set overall. So to sum up, the pros of the approach that we are presenting here is that, first of all, we get more data, one another dimension of data, the text dimension, with quite low effort comparing to, say, human operators. Also, we can theorize about possible gains in few short learning tasks when a new class is introduced into a data set, and we can train a already pre-trained model to recognize that class just by looking into similarities in text descriptions between the new class and the already existing classes. That's something that we're currently looking into, and hopefully we'll find some new interesting results there. The cons of the approach that we're suggesting, obviously, is that first of all, there is just less information with this way when we don't have a unique description for each given image. Also, the fact that we still need, despite all our efforts to automate the text retrieval, we will still need human supervision, which is not ideal, and which is something that we hope to work and to eliminate after all. That's it for me today. Thank you for your attention.